Okay, problem number 3. Uh, I'm gonna read the example. Single phase 1200 kilovolt ampere 240 divided by 120 volt 60 hertz transformer has a no load loss of 3.2 kilowatts and a copper loss of 9.5 kilowatts at rated current. Determine the efficiency for the following load conditions. For A, 1200 kilovolt amperes at unity power factor, 1200 kilovolts at 0.9 power factor, and for C, 1200 kilovolt ampere. I'm sorry if I wrote volts, but at 0 power factor, pure load or C load. First, what was the formula for the efficiency? The formula I wrote it in my notebook, so I won't lose any time remembering. So the formula for the efficiency was the power output divided by the power output plus the losses in the transformer. So the power output, what was the losses? We had core losses and copper losses. So we had P out, and the losses, we had the the core loss, so that is the losses that we have for magnetizing the transformer, the core losses are always the same if the voltage on the primary side is the same. So the core loss, if we don't change the voltage, it stays the same. And we had the copper losses, PCU. So this was the copper losses in the primary and on the secondary windings. So we have those losses also. Now the output power was equal to the voltage V2 times I2 times the power factor. So this was the formula for the output power. And the output power, so we have output power over here, so I'm going to write this down also, copy this. The core losses are always the same, and it is equal to 3.2 kilowatts, so I'm not going to change anything over here, I'm just going to write P, and in index I'm going to write small letter C, and we had the copper losses, which was equal to, if you remember before, that was equal to I2 squared, and the resistance are equivalent. So let's calculate the efficiencies for these these three particular examples. V2 times I2, so these are the rated values. So V2 times I2 will give you 1200 kilovolt amperes. Why? Because the rated, so these are I2 here is the rated value. So I2 V2 times I2 is 1200 kilovolt amperes in this situation. So for A, we have that the efficiency is equal to 1200,000. No, this is 1,002,000. 200,000 volt amperes times the unity power factor, which is equal to 1. So this is 1,200,000 times 1. So V2 times I2 is this. I hope you understand why. Because the rated voltage is 120 volts. So I2, the rated value, is equal to the power at the unity. So unity power that is equal to P at unity power factor divided by the rated voltage. So V2 I2 is equal to the power at unity power factor. When this transfers from here to here. I hope that is understandable for you. So the core losses does not change because it's always the same if the voltage induced and the frequency is also the same on the primary side. So that is equal to 3200 watts plus the copper loss at rated current. So this is also the rated current. It doesn't say it's less or lower. So this is 9500 watts. And this is all equal to 98.95%. For B, eta is equal to, now it says 1200 kilowatt amperes, so that is 1,200,000 times the power factor. Now cosine theta 2 is equal to 0.9, so don't forget that. This is multiplying operation over here. I copy this over here because looking at the formula I have it here and here. The same thing. If the copper loss, the core loss, sorry, I always mix that up, is the same, the voltage is the same, so the core loss is 3200, and don't make this fool you because it says 0.9 power factor, but it didn't say other rated current. So for example, if it said 50% of the rated current, then this would be 0 times 25 times the copper loss at the rated current. So this doesn't, looking at this, this doesn't change if the power factor changes. This here particular changes if and only if the current changes. The resistance of the windings, we say it is the same. So this stays the same, and it is equal to 9500, and this is equal to 98.83%. So as you can see, if the power factor is not unity, then the efficiency lowers. And for C, the power factor at 0, if you have a power factor of 0, then you have a pure inductive or capacitive load. So then you have 200,000 volt amperes. 1, 2, 3, 4, 5 times 0. And I have to copy this here, looking at the formula. Yeah. The copper loss the core losses stays the same. And the copper loss stays the same, but this here is equal to 0. 0 plus something, this is something, so 0 divided by something is something. Okay, so this is 12,700, and this is equal to 0%. So the efficiency of the transformer, if we have 0 power factor, is 0, because it's a reactive power, it's not active power, which we need in real life. So thank you for watching and see you in my next video. Goodbye.